Hi everyone. Today also we are going to learn about electricity. This is electricity part 3. Before starting the lesson today, I would like to remind you what we have learned in the previous part of this lesson. In the previous lesson, we learned about resistance. How the resistance is affected on a circuit and how the resistors are connected to a circuit and what are the types of resistors, fixed value resistors and variable resistors, and how each type of resistors are affected on the current flow in circuits. We have done some calculations relevant to that, how to find the value of a color code resistor as well. Today in this lesson we are going to learn about combinations of resistors. Before starting the main topic, let me show you what we are going to learn today. These are the subtopics that we are going to learn today. At the end of this lesson, children, you will be able to learn series combination of resistors, parallel combination of resistors, to find equivalent resistance of resistor systems, to calculate the current flow through each resistor in the system of resistors. First, look at this particular two circuits. I think this is familiar to you, children. This shows us the impact of resistance to a circuit. When there is a resistor connected, it provides a resistance and then current flow decreases in the circuit. Today we are going to learn how do we combine resistors when we need to arrange our circuits according to the requirements. Right, here in this circuit, children, you can see there are two resistors called R1 and R2. A switch is connected to R2 resistor, but the switch is in the position off. Switch is off. That means no current flows through the R2 resistor. Now, look at the brightness of the bulb. The current flows, total current flows only through R1 resistor, and a certain current flows through the bulb and the bulb is lighted. Now look at what happens when the switch is on. When the switch is on, current flows through both resistors R1 and R2. What has happened to the brightness? The brightness has increased. Brightness of the bulb has increased. Why, children? Don't you have a problem here? When the two resistors are connected and when the current flows through both resistors, how can the brightness of the bulb increases? According to what we have learned, children, we know that when the resistance is high, the current flow decreases and the brightness of the bulb decreases. But here, when the two resistors are connected in this particular way, current flow has increased. That's why the brightness of the bulb has increased. There is a secret behind this. There is a secret behind the combination of resistors here. Now we are going to learn about that, children. Before that, just Think about this, children. Why do we combine resistors? Why do we use more than one resistor in a circuit? If the resistor provides a barrier for the current flow, if it is an obstacle for the current flow, why do we use these resistors? This is the reason. Right, children, look at here. When it is difficult to find a resistor with the required resistance, it is possible to use many resistors in a circuit to provide the required value of the resistance. That means, children, sometimes we need a certain current flows through the circuit. According to the current flow needed, it should be adjusted. The resistance of the circuit must be adjusted. Suppose we need to insert 25 ohm resistor. If there is no 25 ohm resistor, but if we have some 10 ohm resistors and 5 ohm resistors, then it is possible to make 25 by joining those small resistors. That's why we are learning how to combine resistors in circuits. Okay, children? Right. There are two basic methods of combining resistors. One, series combination, and the other one, parallel combination of resistors. First, we are going to learn about series combination of resistors. Children, please observe the three circuits given on the screen. When you carefully observe them, you should be able to understand that number of resistors connected into the circuit have increased. In the first circuit, there is only one resistor called R1. In the second circuit, there are two resistors called R1 and R2. In the third circuit, there are three resistors join R1, R2 and R3. When the current flows through this circuit, children, here suppose the current flows through the circuit is I, right? Here also the total current flows is I. Here also the total current flows is I. Here also the total current flows is I. The same I current flows through R1 circuit and the same I current flows through both R1 and R2 resistors. Same I current flows through R1, R2 and R3 resistors. Here, children, when the resistors are connected in such a way that the same current flows through each of the resistors, it is known as a series combination of resistors. The same current flows through each resistors, children. Right. When there are number of resistors like this, children, what is the final resistance affected to the circuit? How to get the final resistance affected to the circuit? That final resistance is called equivalent resistance. That means if we can use a single resistor instead of all these three resistors here, it is called the equivalent resistance. The way of getting equivalent resistance, when the resistors are connected in series like this is this, children. Look at here. The equivalent resistance is the resistance of a single resistor that could be used in place of all individual resistors. Right now, here we have three resistors called R1, R2, R3. All three are joined in series. Because of all three resistors, there is a certain final resistor affected. That final resistance affected because of all three individual resistors is called the equivalent resistance. This is the way we obtain equivalent resistance of all these three resistors. Here, if the equivalent resistance is R, children, R equals R1 plus R2 plus R3. Did you understand, children? Suppose this R1 equals, the value of R1 is 2 ohm and value of R2 is 4 ohm and value of R3 is 6 ohm. Then what is the equivalent resistance? Equivalent resistance R equals R1 plus R2 plus R3 equals equivalent resistance. If there is one more resistor called R4, then you can put here plus R4 too. Accordingly, R1 equals 2 ohm and R2 equals 4 ohm and R3 equals 6 ohm. Then what is the equivalent here? 2 plus 4 plus 6 equals 12 ohm. 12 ohm is the equivalent resistance of this particular resistor system. Then we'll move to the next. This is a resistor, another resistor with the three resistors connected in series. How to get the equivalent resistance here? See, R equivalent resistance R equals R1 plus R2 plus R3. That's 5 plus 10 plus 15. Answer 30 ohm. Right. Next. Children, when there are many resistors combined in series like this, we can calculate the current flows through the circuit too. The total current flows through the circuit can be found like this. Let me explain. Say, children, here we have already found the equivalent resistance of this particular circuit, right? What is the equivalent resistance? 5 plus 10 plus 15. We got the answer as 30 ohms. Now, this is the equivalent resistance we got. R equals 30. Right? If we know the potential difference of the circuit, here it is given as 6 volt. Total potential difference. When we know both, then it is possible to find the total current flows through the circuit. Total current flows is represented by the letter capital I. This is how we find the total current flow. For this we can use V equals IR equation, children. When we know V and R both, then easy to find I using the formula. Accordingly, the total current flows through this circuit, children. See, we get I, when the I is isolated, we get 0.2. That is, the total current flows through the circuit. Right. Now, move to the next part, children. When many resistors are combined in series like this, there is a possibility to find the potential difference across each resistor. Look at here, children. Here, 3 resistors are joined in series. 3 resistors are R1, R2, R3. Right, ammeter is connected to get the reading of the current flow. Right, when the switch is on, a certain current flows through R1, R2, R3. The same current I flows through R1, R2, R3 all. If we know the current flow I through each resistor, children, then we can substitute into the formula V equals IR. V equals IR formula to get the potential difference across each resistor. When we know the current flow I in the circuit, then the potential difference across R1 resistor V1 can be found by substituting to the formula V equals IR. Let me explain how to do this, right? Here, look at this circuit, children. Here, 2 resistors are given. 2 resistors are connected into a power supply of 3 volt. Okay. Now, look at the question. Which is the way of connecting resistors here? Which is the way, children? Series. This is the series combination. Okay. Next question. Find the equivalent resistance here. How to get the equivalent resistance? Right? We know the equation. Equivalent resistance R always equals R1 plus R2. Suppose this is R1, this is R2, right? R1 plus R2. R1 is 4 ohm and R2 is 2 ohm. Then the equivalent 4 plus 2, 6 ohm. This is the equivalent resistance. Okay, right. Now, see the next question. What is the total current passing through the circuit? What is the total current passing through the circuit, children? When we know the equivalent resistance, we already got the equivalent resistance as 4 plus 2, 6. Then the total current passed through can be found using this particular equation, V equals IR. V 3 volt, I we don't know, R is the equivalent. Equivalent is 4 plus 2, 6. Then when you isolate I equals 3 over 6. This is half. Half means 0.5 amperes. The total current flows through the circuit is 0.5 amperes. Okay. Then look at next question. Find the potential difference across the 4 ohm resistor. When we need to find the potential difference across 4 ohm resistor, suppose we have connected a voltmeter across 4 ohm resistor, right? Then what should be the reading of this voltmeter? It is the potential difference across 4 ohm resistor. Right now, we have already found the current flows. Current I, we already found, that is 0.5 ampere. Right, then it is easy to get the potential difference across 4 ohm resistor. Right, we got the total current I as 0.5. Now, we can apply V equals IR formula for this. See, we don't know. V is the unknown thing. I, we know. I is the total current passes through the circuit, 0.5. And R is 4 ohm. Then 0.5 into 4, 2. Answer is 2. What is that? Potential difference across 4 ohm resistor. This is 2V, 2 volts. Okay. Now, we have come to the next topic of the lesson. This is parallel combination of resistors. So far, we discussed about series combination of resistors. Now, we are going to discuss the next type of resistor combination, parallel combination of resistors. Okay. Look at here, children. Look at here. Look at this particular resistors, the way of connecting the 3 resistors here. Here you can see 3 resistors are connected parallelly like this. And when the total current flows through the circuit is found, children, total current is divided among the resistors and flow. Not like in the series combination. Here the current is divided among the resistors and flow. When the resistors are connected in this manner, it is called the parallel combination of resistors. See the definition. A combination of resistors in which the total current is divided among each resistor is known as the parallel combination of resistors. Children, now we are going to calculate the equivalent resistance of the resistors when the resistors are connected in parallel. Right. See, equivalent resistance is always represented by the letter capital R, children. Equivalent resistance can be found by the equation this. What's this? If the equivalent resistance is R, 1 over R equals 1 over R1 plus 1 over R2. When the resistors are connected in parallel like this, children, here 2 resistors are connected in parallel, R1 and R2. Equivalent is obtained by the formula of this. 1 over R equals 1 over R2 plus 1 over R1. Here we will substitute to R1 and R2 the real values. R1 is 6. Then 1 over R1 equals 1 over 6. R2 is 3. Then 1 over R2 is 1 over 3. How to solve this, children? Now you must isolate R to get the R, get the value of R. This is mathematics, right? This is not science, this is mathematics. For this you need simple mathematical calculations. Right, how to find the value for R here? 1 over 6 plus 1 over 3. What's the common denominator? 6. Right? 1, 6 times 1 and 3 times 2. right? Equals 1 over r. This is equals 3 over 6. If 1 over r equals 3 over 6, children, like this, 1 over r equals 3 over 6. You can put the cross multiplication, then you get 3r equals 6. 3r equals 6. Then what is r? R equals 2 ohm. See children, see the two resistors are 6 ohm resistor and 3 ohm resistor. When the two such resistors are connected in parallel, the equivalent has decreased. See, equivalent is 2 ohm. That means final effective resistance for the circuit has decreased. This is the secret behind connecting resistors in different manners, children. That means when the equivalent decreases like this, the current flow through the circuit increases. When the current flows increases, the brightness of the bulbs in the circuit must increase. If there are bulbs connected here, children, definitely the brightness must increases when the resistors are connected in parallel. Understood, children? Right. Okay, then we will do some more calculations. We will do some more calculations regarding the parallel combinations. Okay, right. Here, another two resistors connected in parallel. How to get the equivalent resistance here? You can see equivalent resistance R, then 1 over R equals 1 over R1 plus 1 over R2. Here R1 is 10, R2 is 5. Then 1 over 5 plus 1 over 10. Then when the R is isolated, you get 10 over 3, that is 3.33 as the answer. See the difference, children. Two resistors are connected parallelly. One is 5 and one is 10. When both resistors are connected parallelly, what is the equivalent resistance? Equivalent resistance is 3.33. That means the total effective resistance has gone down, decreased when the two resistors are connected in parallel. Okay, right. Now, look at the same circuit, another circuit. Two resistors are connected again to a 6 volt power supply. What is the way of connecting resistors here, children? The way of connecting resistors is parallel combination, right? Next question. Find the equivalent resistance here. Find the equivalent. Now, how to get the equivalent, children? Right? Always use the equation before substituting to the, before get the answer, children. Always you must write the equation relevant. Equivalent, if the equivalent resistance is R, 1 over R equals 1 over R1 plus 1 over R2. Here R1, suppose R1 is 12 and R2 is 6. Then 1 over 12 plus 1 over 6. Then common denominator 12. 1 plus 2 equals 1 over R equals 3 over 12. Again cross multiplication. I'll take it to the up, children. 3R equals 12. Then how to find the value for R? R equals 12 over 3, 4. R equals 4 ohm. This is the equivalent resistance. Okay, children? Right. Then move to the next one. Again, what is the total current passing through this circuit, children? What's the total current passing through this circuit? And again we have to find the current passing through the 6 ohm resistor only. Right, let me explain how to find the total current passing through the circuit. Here we got, children, we got the equivalent as 4. We found the equivalent of these two resistors as 4. When we know the equivalent resistance, then it is possible to get the current flow. V equals IR. Always you have to use the relevant equation. V is 6. I we don't know. R is the equivalent resistance. Equivalent is 4. Then what is I? To get I, both sides can be divided by 4. Then I equals 6 over 4, that's 3 over 2. 3 over 2 equals 1.5 amperes. 1.5 amperes is the total current flows through the circuit. Right now suppose this is the total current I, right? Then I equals 1.5 ampere. When it comes here, children, this 1.5 ampere current divides among the two resistors and travel. When the current is divided, children, the amount of current flows through each resistor is decided on the value of the each resistor. Then our next question is, find the current passing through the 6 ohm resistor only. We need to find the current. Suppose this current passing through 6 ohm resistor only is I1. It is I1. Then how to get I1? Here also we can use the same formula, same equation, children. V equals IR. See, V equals IR. Here I is I1, right? R is 6 ohm. Then the potential difference across this 6 ohm resistor is 6V. The potential difference 6V is common for both. The potential difference across both resistors is 6V. Here V is 6, then we don't know I1. R we know, that is 6 ohm. R is 6 ohm. Then when you isolate I here, both sides must be divided by 6. Then I you get as 1 ampere. I equals 1 ampere. Then the current passing through 6 ohm resistor is, children, 1 ampere. Then the total current is 1.5. If the total current is 1.5, then what should be the current passing through the other resistor? 12 ohm resistor must be 0.5. Okay, right. Move to the next. This is another question, children. Look at the circuit given here. What is the equivalent resistance of this circuit? How to get the equivalent resistance here, children? See, first you have to find the equivalent between these two. These two are parallel resistors, right? For these two, this one is in series. So, first you have to find the equivalent between 6 ohm resistor and 3 ohm resistor, right? How to get the equivalent between 6 ohm and 3 ohm resistor, children? We know that 1 over R equals 1 over 6 plus 1 over 3. 1 over 6 plus 1 over 3. Then the answer (3 over 6) equals 1 over R. Then R equals 6 over 3, that is 2 ohm. Right. Equivalent between these two is 2. Right. Now we got the equivalent of 6 ohm and 3 ohm resistor as 2. Then how to get the total equivalent? Now for these two, this one is in series. Then you have to add the equivalent of 6 ohm and 3 ohm resistor to the 4 ohm resistor to get the total equivalent. Then the equivalent of the circuit is completely 2 plus 4. 2 plus 4 altogether 6 ohm. 6 ohm is the equivalent resistance of the complete circuit. Understood, children? Right. Okay. Again, same circuit. Some more question. What is the total current passing through this circuit, children? Total current. How to get the total current passing through the circuit? Right? Total current can be found. Total current is I always, right? Now we have already found the equivalent of the complete circuit. Equivalent between these two is 2 ohm and 2 plus 4 altogether 6. 6 ohm is the complete equivalent. And the potential difference of the circuit is 6. V is 6 and R also 6, equivalent R, then I. Then how to get I, children? When you isolate I here, both sides must be divided by 6. Then I, as the I, you get 1 ampere. This is the total current passing through this circuit. Then find the potential difference across 4 ohm resistor here. Children, potential, suppose the potential difference across 4 ohm resistor is V. Right? Now we have found the current flow through the 4 ohm resistor. Current flows through the 4 ohm resistor is 1 ampere. And then we can substitute again to V equals IR formula. We don't know. This is what we don't know. I, the total current, already we have found 1 ampere. R, 4 ohm. Then 1 into 4, 4. 4 volt is the potential difference across 4 ohm resistor. Okay, we will move to the next question. Find the current flow through the 3 ohm resistor. Right, now we have already found the current, total current flows through the circuit as 1 ampere. And also we have already found the potential difference across 4 ohm resistor as 4 volt. Right. Then what you must know, children, if the potential difference across 4 ohm resistor is 4 here, definitely the potential difference across these two must be 6 minus 4, 2V. This must be understood, children, because the total potential difference is 6 volt. If 4 volt is given to this particular resistor, the remaining potential difference must be given to the 2 resistors connected in parallel. Therefore, the potential difference across 3 ohm resistor is 2 volt. Then how to get the current flows through this particular I1, through this particular circuit? V equals IR. V is 2 volt. I1 we don't know. This is what asking in the question. R is 3 ohm. Then when you isolate I here, 2 over 3 is, that's 0.2 over 3 is 0.666. That means 0.67 amperes. This is the current flows through 3 ohm resistor. Now look at the last question of this particular question. What happens to the total current flow in the circuit if the 3 ohm resistor is removed? See children, if we remove this 3 ohm resistor, then the circuit becomes like 2 resistors are connected in series. 6 ohm and 4 ohm resistors are connected in series. Now what's the equivalent when the resistors are connected in series? 4 plus 6. Then the equivalent is 10 ohm. 4 plus 6 is 10 ohm. That means now the equivalent has gone up, increased. Then definitely the total current flow must be decreased. Then the answer is, the question is, what happens to the total current flow? The answer must be total current flow decreases. Right. Now look at here children. When there is a large number of equal resistors are combined in series, how to find the equivalent resistance? Before go for this children, I want to show you how the equivalent is affected to the total current flows when the resistors are connected in series and parallel. So, we will do a simple activity and move to this part. Right. Okay. Look at here children. I have arranged 2 circuits. Here. Right. Suppose these are equal filament bulbs, torch bulbs with equal filament resistances. Right, they have all equal filament resistances. When the bulbs are connected like this children, this is similar that resistors are connected in series, right? Here you can see 3 bulbs are connected in series. This is, suppose that 3 resistors are connected in series. Here the 3 bulbs are connected in parallel, and assume that 3 resistors, equal resistors are connected in parallel, right? Now I am going to switch on both circuits and show you the difference of the brightness of the bulb. See, when the switch is on here, you can see the 3 bulbs are lighted with a very less brightness, very low brightness. That means the total current flows through the circuit is very low. You know that when the resistors are connected in series, the total resistance increases equivalent increases and this results a decrease in current flow. Due to that, the brightness of the bulb very low. Now look at here. See the difference of the brightness, children. Here you can see the brightness is high than this. See. Why? Because when the resistors are connected in parallel, equivalent resistance decreases and current flow increases. Due to increase of current flow, the brightness of the bulbs high. Okay. Now, look at this, children. What's the topic is given here? When there is a large number of equal resistors are combined in series, how to find the equivalent resistance? Look at here, children. If we have 3 resistors, all are same values, right? Then do we need to add one by one them, children? 5 plus 5 plus 5. Normally, equivalent resistance of the series combination is obtained by adding, getting the sum of all individual resistors. Here, all resistors are equal, then the equivalent 5 plus 5 plus 5. Instead of adding all one by one, children, we can multiply the number of resistors with a value of one resistor. See, value of one resistor is 5. Number of resistors 3. Then 5 into 3 also we get the equivalent. Let me explain this clearly, children. Suppose we have, in a circuit we have 100 equal resistors of 5 ohm of each, right? Then can we add all up to 100, 5 plus 5 plus 5? No, we can't. Then what we have to do? You have to take the value of one resistor. Value of one resistor is 5. How many resistors? 100. Then you have to multiply 5 by 100. That's you get equivalent resistance easily. If the value of one resistor is R, right? If the value of one resistor is R and if the number of resistors is N, we don't know what the exact number of resistors. If the number of resistors is N, then how to get the equivalent resistance, children? N into R, that's NR. Right. Okay. Then look at here. When number of equal resistors are combined in parallel, children, how to find the equivalent resistance easily? See, let me explain this. Right. Here, in this particular circuit, 2 resistors are combined in parallel. The value of one resistor is 10. Then equivalent resistance, if the equivalent is R, children, here you know 1 over R equals 1 over R1 plus 1 over R1. R1 and R2 all are 10. Then 1 over 10 plus 1 over 10. See. Then 2 over 10 equals 1 over R. Then cross multiplication. 2R equals 10. Then R equals 10 over 2. R equals 10 over 2. Here, there are 3 equal resistors of 10 ohm each, right? Then how to get the equivalent? 1 over R equals 1 over 10 plus 1 over 10 plus 1 over 10. See, then 3 over 10 equals 1 over R. Then R equals 3R equals 10. R equals 10 over 3. When there are 4 such equal resistors are connected in parallel, then you should be able to understand, children. Nothing to calculate, right? Here 1 over R equals 1 over 10 plus 1 over 10 plus 1 over 10 plus 1 over 10. Then 4 over 10, that means R equals 10 over 4. What can you understand by this, children? See, in the first case, R equals 10 over 2, then 10 over 3, then 10 over 4. If we have 5 such resistors, then R equals 10 over 5. There's a pattern here. We can understand a pattern here, children. See, that means when there are large number of equal resistors are connected in parallel, equivalent equals value of one resistor. 10 is the value of one resistor here. Here 3 is the number of resistors. Here 4 is the number of resistors. Then equivalent is equal value of one resistor over number of resistors. Right? This is the equation we derived by this. When there are n number of resistors of R value available in a circuit with the same R value, equivalent resistance R equals value of one resistor over number of resistors. Here value, if the value of one resistor is 10 and if number of resistors are 100, 10 over 100, then the answer 0.1. This is how we get the equivalent easily when equal resistors are connected in parallel. With that, we have come to the end of the lesson. This is what the content that you must learn, children. Now I am going to evaluate you, children, right? I want to know whether you have understood the concepts properly. Please look at these questions. I got all these questions from past papers. See, what is the total resistance of this circuit when the switch SC is on? Right. Now you might think, children, here there are 2 resistors and another S switch are connected parallelly and another 2 resistor is connected in series. Children, remember, when the switch A is on, the current doesn't flow through the resistors. Why? When the switch S is on, children, here this is the path that there is 0 resistance. The current find the path with the 0 resistance. That current finds the easy path to go, children. So here in this case, current doesn't flow through both resistors, these 2 ohm and 2 ohm. When the switch is on, current easily passes through this and only this 2 ohm resistor is affected to the circuit. Then what is the total resistance here? 2 ohm. Answer is 2 ohm. Right. Okay. Go to the next question. Which of the following has the equal equivalent resistance between P and Q? See, children, here 3 ohm resistors are connected in parallel. How to get the equivalent? Value of one resistor 3. Number of resistors also 3. Then 3 over 3 equivalent is 1 here. Then this is in series to this. Then 1 plus 2, 3 ohm is the equivalent of this. Here the equivalent is, see, all 2 ohm resistors, value of one resistor 2 and number of resistors 3. Then 2 over 3 is the equivalent here. This is 0.66 plus 2, then 2.66 is the equivalent. Here 4 ohm resistors, 2 4 ohm resistors are connected. Value of one resistor 4, number of resistors 2. Then equivalent is 2. 2 plus 1 equivalent is 3. Then what are the circuits with equal equivalent resistance? This. First one, A and C. Answer, third answer. A and C. Now go to the next. Which is the current I produced by the cell here? Here children, to find the current I, you need to find the equivalent here. Here equivalent is value of one resistor over number of resistors. That is 18 is the value of one resistor. Number of resistors 2. 18 over 2, 9. 9 is the equivalent resistance. Then current flow can be found. V equals IR. V is 6. I we don't know. R 9. Then I equals 6 over 9. That is 2 over 3. 2 over 3 amperes. Answer this. 2 over 3. Then the next question. In which of the instances below can the glow of the bulb in this circuit can be increased? In which of the instances below can the glow of the bulb in this circuit can be increased? Here the answer, when one more 2 ohm resistor is used in parallel. When one more 2 ohm resistor is used in parallel, you know that equivalent decreases when then the total current flow increases and the glow of the bulb can be increased. Answer is this. With that, we have come to the end of the lesson, children. I hope that you got a very good understanding of these concepts in physics. Thank you very much for being watching this, children. Goodbye, children.